Okay, so in this particular case, we've been asked to balance this equation H₂SO₄ plus NaOH, and that produces Na₂SO₄ and H₂O. Right, so we need to effectively get this to a state where it's balanced, and we need to only use whole numbers in our final answer as far as like what the balance equation would be. Now, one of the things you might be able to see just from visual inspection is that this is effectively a neutralization reaction, right? We've got an acid and a base producing a salt and water. But anyway, not to get into the reactivity, let's focus on actually balancing the equation. So one of the first things I'm going to do is I'm simply going to do an audit of the equation itself. So I'm going to try and get some sort of accounting of what's the actual number of atoms of each element on the left hand side and on the right hand side of this equation. So we've got H, we've got S, we've got O, and we've got Na. So these are effectively the unique elements we've got, right? So that would be left hand side, right? And on the right hand side, more or less, we've got the same, right? So H, S, O, Na, right? Okay, so let's actually do the accounting. I would invite you, if you'd like, to actually doing this process of accounting, work out, well, what are the numbers of each, for each element, how many atoms do we have of each, basically. Okay, so on the left hand side, we've got H2, and then we also have a H in the NaOH, right? So that would be 3, right? So for H we've got 3. Okay, for S we've got it only occurs here, it doesn't occur in the NaOH. So we've got SO4, so that would be 1, right? And for oxygen, we've got O4, and then we'll have NaOH, right? So we've got effectively 1 plus 4, right? Which would be 5, right? So 5. And for Na, we've only got it occurring here with NaOH, so we only have it basically occurring once. Okay. If we take our attention now to the right hand side and effectively go over the same process, for H, we've got an occurrence twice here in H₂O, so that would be a 2. For S, we've got it occurs once, right? So that's basically the same as the right hand side, it occurs once. And oxygen, so we've got SO4, so we've got O4, so it's occurring 4 times plus the in H₂O, so that would be 4 plus 1, right? So which is again it's 5, right? And then for Na, we've actually on this side we've got Na2, and it doesn't occur here, so that's a 2. And so if you compare the left hand side and the right hand side, you can see that for sulfur, for S, we actually have, it's the same on the right hand side and left hand side. For oxygen, it's the same on the left hand side and the right hand side, but for hydrogen, it's not the same. And for sodium, it's also not the same. So for Na, it's not the same. So we do want to look into how we can try and get this balanced. So specifically for sodium, in the case of sodium, we have it in one place on the right hand side, we have it in one place in the left hand side, and it's more, we got more on the right hand side than on the left hand side. So in this case, if we were to put a 2 in front of the NaOH, we would probably find that we can now get it to be Na to be the same as the right hand side, right? So this is one of the first steps I'm going to take. So let's see what the consequence of that is. So I'm going to write out the new equation if we do that. So we would effectively have H₂SO₄ plus NaOH. Well, no, not NaOH. We'll have actually, so as I said, we're gonna have 2 NaOH, right? Yep. And then Na₂SO₄ plus H₂O. Okay. So let's do an audit again, and let's look at what we're actually going to get out of this. Having put the 2 in front of the NaOH. So if you put the left hand side and the right hand side, H₂SO₄ Na₂SO₄, right? So for hydrogen, if we do our counting up of the hydrogens, at this stage, we have the 2 from the H₂SO₄, but now we also have the number of hydrogens in the NaOH is overall changed because we've got the 2. So that would be, instead of it adding up to 3, because we've got 2 here plus the 2 here, it's going to be 4. Right, so for hydrogen, that's actually going to be 4 now. For sulfur, we've not changed the H₂SO₄, which is the only species in which the sulfur occurs, so that's still going to be 1, right? For the oxygen, we've got the 4 oxygens from the SO4, but now it's added to, instead of being added to 1, it's going to be added to 2 oxygens from NaOH, right? So that's effectively it's going to be 6, right? And for sodium, as we just saw, we added a 2 to try and get the sodium to 2. So simply put, that's going to be a 2, right? And on the right hand side, well, we didn't change anything, right? It's going to be the same. So straightforward, it's going to just be 2, 1, 5, 2, right? As above, right? Okay, so at this stage, what do we have? So we have now that the sodiums appear more balanced, but having taken that measure, previously we had the same number of oxygens, now we don't. In terms of the hydrogens as well, we don't have really have a balanced number of hydrogens. We've got 2 less on the right hand side compared to the 4 that we have there on the left hand side. Okay, so what can we do to modify this? Because as you can see, the main issue is that we have an insufficient number of hydrogens and an insufficient number of oxygens on the right hand side. Well, clearly the species on the right hand side where we can modify that, and specifically that the number of hydrogens and oxygens, is the H₂O. So that's where I'm going to focus my attention, on the H₂O. And what we can do, if you look at it, we need 2 more hydrogens and we need 1 more oxygen. And if we were to put a 2 in front of the H₂O, that would effectively enable us to achieve that. So that is what I'm going to do. So I'm going to do H₂SO₄ plus 2 NaOH, and that produces Na₂S. I think that 2 is a bit too big. So Na₂SO₄, and we're going to put our 2 that we discussed. So we're going to put 2 H₂O here, right? Okay, so if we do our counting once again, and as I mentioned, we didn't modify anything on the left hand side in this instance. So this is on the left hand side, it's going to be the same. Let's see, let's use this. On the left hand side, it's going to be the same as what it was before. So it's going to be literally just the same thing. So H₂SO₄ Na, that's going to be 4, 1, 6, 2. But now for the right hand side, as you saw, we did change the number of specifically of hydrogens and oxygens, right? So H₂SO₄ Na. So the first thing I'm literally going to do is effectively ignore the hydrogens and oxygens initially. I'm going to put the auditing of the number of sulfurs and sodium because it's going to be the same as before. We didn't change that, so that's going to be 1 as literally as before, and for sodium it's going to be 2 as before. But for hydrogen and oxygen, let's do the count for that. So for hydrogen, we put a 2 in front of the H₂O. We don't have any hydrogens in the Na₂, right? So 4 species, which is going to be 2 multiplied by H₂, which is going to mean that we have 4 hydrogens, right? And for oxygen, we've got oxygens in both species, so we've got O4, so that's going to be 4 oxygens, and then we've got 2 O, so it's going to be 4 plus 2, right? Because it's going to be 2, right? So which is going to give us 6, isn't it, right? Now, if we now compare our audited numbers from the left hand side and the right hand side, we've got 4, 4, 1, 1, 6, 6, 2, 2. So effectively at this stage we can say, well, the left hand side and the right hand side are balanced. And as the question specifies, it says use only whole numbers when balancing the equation. This is effectively what we've been able to use. We've used whole numbers, okay? And so effectively the main thing was we put a 2 in front of the NaOH, 2 in front of the H₂O. So we can just add that here, right? Any standard equation, if we need to put a 1 in front of something, then we don't actually need to put a 1 in front. Well, you don't need to put a number in front of it. So the other two I'm just going to leave blank effectively. Okay. All right. So that would be here. This would be our balanced equation. Okay.